talk about something called Markov chains. Okay, bear with me, please, because to me this is utterly fascinating stuff. Okay, a Markov chain is like their name. It's like a data structure and an algorithm kind of thing. They're named after Andrei Markov, and they're mathematical systems that hop from one state to another. A state being a situation or set of values. For instance, if you made a Markov chain model of a baby's behavior, you might include playing, eating, sleeping, and crying as states, which together with other behaviors could form a state space, a list of all possible states. In addition, on top of the state space, the Markov chain tells you the probability of hopping or transitioning from one state to any other state. For example, the chance that a baby currently playing will fall asleep in the next 5 minutes without crying first. So here's a really simple Markov chain, and we can speed it up here. Like, this is a really simple thing where the odds of transitioning from A to B is 50%, and from B to A is 50%. So what you would think is like it would just switch back and forth, but in reality, that's not how probability works, right? So these chains are, sometimes it'll hit B and it might spin on B for a few times and hit A and spin for a few times. Sometimes it might hop right back and forth. It's like a series of coin flips that are dependent on each other. And you can sort of represent it like in a state chart like this, okay, where like the rows and the columns represent the different states, and then in the boxes in between it, this represents the probability of jumping. The probability of A going to A is 50%. So if we increase that, so make it more likely that A will stick with A, right? And as we'll see, A stays there longer. It does still have a 12% chance of popping over to B. Oh, and there it did. B's got only its 50% chance, so it's way more likely to hop back to B from A. And there it goes, right? And you can really mess around with these things and dial them in. So going from B to B, yeah, you can change the probabilities, and that affects the state. So why do we even do this? Who cares? There's a bunch of different applications for this. One of which is like auto predict on your phone, right? So when you start typing in letters and words, it's presenting you with what it thinks the word should be based on the probability of what that word would probably be based on a Markov chain of the letters. So when you start typing in B, it looks for all the words that start with B and puts the most likely ones at the top of that list. And as you add more letters to it, that list narrows down. Okay, so in this, let me see if I can make this bigger. Yeah, let's see if I can pump that up a bit. So in this representative example, we've got a real set of data here. For example, check how frequently a new dam will overflow, which depends on the number of rainy days in a row. We start off with this real pattern of data, right? It rains, it rains, it rains, it rains, it rains, and then it eventually stops raining. In other words, the likelihood, here it stopped raining, it's sunny. In other words, the likelihood of it being rainy is much higher if the day before was rainy. So one way to simulate this would be like half of the days you have a 50% chance you're flipping the coin every day for rain. And if you did that, you'd generate something like this sequence down here, which if you look at it compared to the original sequence, just doesn't seem like that sequence, just doesn't seem very much like it. So we can mimic the stickiness with a two-state Markov chain. Wait, let me shrink it again. Yeah. So now, if we model it based on these probabilities now, and I'll crank up the speed to make it happen faster, now we get a simulation that is much closer to our original data set, meaning like long chains of rainy days and long chains of sunny days. So in the hands of meteorologists, ecologists, computer science scientists, financial engineers, and other people who need to model big phenomena, Markov chains get to be quite large and powerful. For example, the algorithm Google uses to determine the order of search result, called PageRank, is a type of Markov chain. Okay, so in other words, they look at a link, or they look at a page and they look at all its links, and they look at all the people that link to a page, rather. And the more people that link to a page, the higher in likelihood that's going to match what you're searching for, right? That's involved, probabilities involved. Okay, great, Dan, who cares? What can you do with this? Well, with just a little bit of programming. This is something I want to bring to this show, is that, like, I love programming. But I taught myself. Okay. I made a good living out of it, but it's something that I do for fun because it's just interesting. So let me show you an example here, something that I did with Markov chains. So I've got all the Hardy Boys titles here, and I can click generate, give it a minimum number of words that I want in the output of my Hardy Boys title. So I'll say 5 words and I'll say generate. Okay. Passport to danger in the snow leopard, right? That's not one of these titles, but it's using the words and kind of writing in the style of these words by using Markov chains. So let's look at this visualization I created of the data, okay? I'm going to hit this debug button here, and that's going to show us even more. Okay, but what is this? I'm going to hit generate. Okay, this is a Markov cloud, and I have complete control over the physics of this in this scenario. But what did it do? It created this Markov chain, and here's what it is. Here's the secret of the Markov chain, right? There ain't that much to it. It's a data structure. It's a JavaScript object. All I do is take every single word and put it in this list, and then give that word a list of all the words that follow it in the text. So the word in shows up a bunch of times. In fact, the word in is in these titles 1, 2, 3, 4, 5, 6, 7 times. And it always says in the, and then in Gator, and in the, and in warp. So with this structure, the most likely word to follow in is always going to be the. And so in my Markov chain here, when we generate it, what I just did is I sort of highlight the colors. So if we look at what we got the prime time crime in the extreme. So it started here. You got the, which, as we can see, connects to prime, right? Oh, here's the original word, the prime, followed by time, followed by crime, followed by in the extreme. Okay, weird, right? It's neat. You can do really cool things with this technique. And now if we look at the visualization, what we'll see is the words are all connected, or are they? Some of them are not. We see things like here, Motocross Madness is a title that does not share any other words with the rest of the titles. So we can see how the titles, we can see sort of the connection between words in this style, and it gives us, let's generate some Hardy Boys. We can change the number here, make it a little shorter. The Secret of the Black Rhino. Passport to Danger in Gator Swamp. The Search for the Snow Leopard. Day of the Counterfeit Criminals. None of these, Trick or Trouble ×2, right? These all sound like Hardy Boys mysteries, but are not Hardy Boys mysteries. Oh, dude, do I love that. What do I love more than that? Okay, what else can you do with this? Let's see. I'm going to go to my Markov chains, and I had another one here that I would like to show you guys. I thought that was the one, but I have another one that I did. Another Markov. Yeah, this is the one. Okay, this one is kind of cool because this one we use to actually generate text. Hey, Brian Garside of Managed Comics. Hey, Brian. Thanks for watching, buddy. This is interesting to geeks like me and Brian. Brian created Managed Comics. I'm going to have him in here soon, maybe next week. I'm going to catch up with you soon, Brian. I'm sorry I haven't been in touch. Okay, let's take a look at what we can do here with Markov text generation. So you can seed this. In this case, I seeded it with the Declaration of Independence. Okay. So let's hit generate until we need at least 7 words that work. The unanimous declaration of rights themselves invested with certain unalienable rights that they are absolved from time transporting us. The history of and eat out their exercise. Like these things all kind of like almost sound right. It's fun to use this stuff for if you needed to generate like lorem ipsum text type text, you know what I mean? Like text filler, especially somewhere like in comics or whatever, where you have like somebody reading a newspaper and you want it full of stuff, but you don't want to steal somebody's other stuff, but you don't want it to say lorem ipsum and just be complete gibberish. Well, you can just crank up your Markov chains and generate that text. You can generate them much longer, much more programmatically than this. But how much is there to this? Well, in this case, I use jQuery a lot when I do programming for the web. jQuery is a library that makes cross-browser web programming or DOM manipulation easier. And I wrote a plugin called Markov Maker, okay? And you can find this thing. Maybe I'll put a link down there. You can find it and use it. And it's as easy to write the program that you're seeing here. You know, it's 125 lines of code or so. You set up a few different things to do it. And you set up, like, for instance, what are your terminators? What do you consider a punctuation mark? What do you consider the end of a sentence? Just so that it can build the Markov chain. I showed you before, the Markov chain is a really simple structure. I kind of struggled with it one time because I was like, I got to figure out the percentage probability of choosing the next word and add that into a data structure so I could look it up. But it ended up being so much simpler by just putting in an array and putting an array of all the words that follow it and just randomly selecting an item out of that array. That's exactly the same as using the probability of selecting one. If you're randomly selecting one and one word is there more times than the other, you've increased the probability. So the algorithm is extremely simple, but it's extremely fun and useful, the kind of stuff that you can do. So you want to play around with this. Here, I'm going to take this URL and I'm just going to put it in the chat. Okay, I'm gonna throw this up there, and I recommend you take a look at it. And you can fiddle around with it, you can fork it, you can do whatever you want with it. If you want the other one, you can get to it too by just clicking on my face, and you can see this fiddle. I like this one, and I think I brought this one up for a reason because I do a lot more with the visualization here. I'm using a library called Viz.js, which has this built-in physics simulation. Let me generate this again. And then I use that to sort of like illustrate. So for each Markov chain, you can see the sort of brighter green ones are like the beginning of a title. And the yellow ones are the terminator for the title, the last word in the title, right? So you can even just by looking at this sort of like choose your own. What's great, you can sort of choose your own and walk your way through the chain, the prime, time, crime, whatever. You can zoom in and out of this. Wait a minute. Let me get this back into this size. You can zoom in and out of this thing. And it's got complete physics as well on these things. So you can move them around. And I added the debug mode in here because you can control the physics. It's pretty neat. Like if you want to go into a mode that's a little easier to understand, we'll go into hierarchical mode. And this makes it a little easier to sort of see the structure of this thing, right? You can see how the words kind of break down, always starting at the top, how the is obviously the most likely thing to start with. And then these other guys are just sort of floating out in space, unconnected to that. Now, the beauty of this is you can put whatever you want in here. So you want to use this to generate something else or add to this list, you can just put in whatever you want in here. So we could look for, like, you know, maybe like Nancy Drew. You could put in Nancy Drew titles or anything with kind of similar that follows a pattern. And if you're like me, you're going to have a lot of fun just doing this, just clicking on this thing. Wait a minute. Just clicking on this thing. That's what we want. Yeah. And generating new titles. I think it's as fun as can be. You can mess with debug mode as well to mess with the physics. And then you can go in and mess with the actual source code that I wrote and write your own thing. Like, learn how to do this. So, man, have fun doing that.